For float numbers, I will just give you the basic idea behind how the numbers are stored and why they are called as float. Suppose I have a number that is 163.52, then this is having a decimal point, right? If this number has to be stored in computer's memory, then decimal is not stored. We want to avoid decimal. Then how it can be avoided? How we can remove it? So we move this decimal point from there. So it means we float that point from there. So that's why it's called as floating point. So in which direction we want to float? So you can move in this direction also, both the options are there. So let us move it in that direction. So let us make it as 16352 and then decimal point. So this decimal point has moved here, means when this decimal point will move there, if you multiply the number by 100. So I'll bring back the point here and I will say I'm multiplying it by 100. So then divide it by 100 also. This becomes 1. So multiplying and dividing the number by 100. So this becomes 16352. When you multiply it by 100, this decimal moves out. And then this is 1 by 100. So this is 16352 into 10 to the power of minus 2. Now decimal we don't have to show, it is understood, that is after the last non-zero digit decimal is there, it is understood. So we don't have to represent decimal number. So floating point number don't really store decimal in the memory, but they represent a decimal number. This is how they represent decimal number. And this representation, this portion is called as mantissa, and this portion is called as exponent, right? An exponent is always 10 to the power. So this is understood, it is 10. So this is also written as 16352 e minus 2. So e means 10 to the power of minus 2. So this is how numbers are represented, decimal number. So this is also called as a scientific representation. So this is just a basic idea I have given you how floating point numbers are stored. Actually, it is stored in binary form. So there is a procedure for conversion of this one. So if you want, you can study it, you can explore it, right? So as a programmer, you should have little idea about this one. So it is represented in the form of mantissa and exponent. This is important. Now next thing, float takes 4 bytes, and the method of representation is actually made as a standard, and that is IEEE standard, and that standard number is 754. If you know this also, it's better. Every electronic device follows the same standard, so it is standardized internationally. So this is a standard followed by every electronic device, and they all follow that method. So this is just the idea about that method. Now next thing about double. So why we have a double? So if you want more precise value in decimal point, then you can go for double. Means after decimal, if you want a number 12.539462, so 1, 2, 3, 4, 5, 6 up to 6 digit float is suitable. If you have more number of digit, then you can go for double. So after decimal point, if you want more precise value, more detailed value, then you can go for double. Most of the times we compromise with just 2 digit after decimal, or 3 digit we may take, right? We stop there. But some cases every digit is important after decimal. So if you have more and more digits, so that is more accurate value. It is treated as accurate value or precise value. So if you want more values after decimal point, go for double. So this may support up to 6 to 7 digits after decimal, and this may support up to 14 to 15 digits after decimal. So this is all about floating point data type. Now let us come to character. Characters, like in English language, we have alphabets like A, B, C, so on to Z, or we have lower cases A, B, C, and so on to Z. These are alphabets. So basically computer doesn't support alphabets. Then we use numeric values instead of these characters. So those numeric codes for English alphabets are called as ASCII or ASCII, American Standard Code for Information Interchange. So these ASCII codes are there for uppercase English alphabets, lowercase English alphabets, and the digits, numeric digits also And for other special characters, anything that you find on the keyboard, for everything there is a ASCII code available, all the special characters. So this is common thing. This is supported by other languages also like C and C++. But in internet, as it is connecting people globally with various languages, so internet supports multiple languages. So programming language should also support multiple languages. So there are codes defined for all natural languages, various natural languages like English, Hindi, Bengali, Marathi, German, Spanish. For various languages, codes are there. So those codes are called as Unicodes. Unicode. And these are also standardized. Every programming language supports Unicodes, the latest language supports Unicodes, and they follow same codes. So these ASCII codes actually becomes a part of Unicode. Like for all other languages, we have a Unicode. So in this, English is also one of the language. So if you want to study what are the codes for your natural language, right, like your mother tongue, then you can go to unicode.org and find out the codes for that one. So there is a chart available, charts are available, so you can search for your language and you can find out the codes and you can use those codes. Now let us see what are the codes. See, for English language, capital A is 65, numeric value 65, and this is capital Z is 90. So it means 65, 66, so on to 90. And for lower cases, it is 97 and 98 to 122. And for this 0 so on, this is 48 and this is 49 to this is 57. See, these are symbols, right? Symbols, and these are codes for those symbols. That is not a number. Don't call it as a number 9. It's a symbol 9. And its code is there. Like this is symbol Z and its code is 90. Same way, symbol 9, its code is 57. So these are the codes. And the ASCII codes actually range from 0 to 127. This is the range for all other special characters included that are within 127. So for the largest value 127, only 7 bits are sufficient. So ASCII codes are only in 7 bits. But when we talk about supporting various natural languages, 7 bits are not sufficient. We need more spaces, right? So that is the reason Java takes 2 bytes for a character to support Unicode. And that too, it takes the numbers that are positive numbers only, 0 to 65535. So only positive numbers it allowed, because there is no use of negative numbers in terms of characters. So this is about character data type. And the last thing is Boolean. So this Boolean data type allows only true or false. So for storing true or false, only 1 bit is sufficient, right? If this bit is 0, we can say positive, and if it is 1, we can say negative. This is possible. But in Java, how many bits it takes, it's not defined. It depends on the runtime, that depends on the JVM. And Java allows only 2 values, that are true and false. That's all. So that's all. This is about data types. So I have gone into detail. I have shown you how negative numbers are stored, why we have 4 types of integral values, and how floats are stored. So this is the extra things that we have learned in greater detail that are helpful for utilizing these data types efficiently and also for answering job interview questions. So the next video I will talk about variables.